So looking at chapter 2 and functions and graphs, section 2.1, and first of all we're just looking at the modulus function. This is a sort of neat little section, more or less on its own. We come back to modulus functions later on in the chapter, I think, when we look at section 2.5, really, with graphs transformations and combining transformations and things. But there's just an extra little thing we've got to throw in. Now, if you haven't met the modulus function before, it looks like this. 2 lines, and we put something in the middle. So if I put a 6 in the middle, or I could put a -3 in the middle, just something goes in the middle. Now what it means, it's sometimes called modulus, sometimes called the absolute value, okay? And what it means is we're not going to worry about whether it's positive or negative, we just want the size. So how big is the number 6? Well, it's 6. How big is the number -3? The size of it is 3, okay? It's 3 away from 0, it doesn't matter that it's in the negative direction. So when you've just got numbers, if you put these lines around them and find the absolute value or find the modulus, it means just ignore the minus signs, okay? How does that work when we're looking at functions? Well, it would look like this. F of x, and I'm taking the example from the book. How does this look? Well, if you want something like f of 5, and again I'm taking the example straight from the book here, I get 2 times 5 take away 3 plus 1. Well, 2 times 5 take away 3 is 7 plus 1, and now we're asked to do mod of 7. Well, mod of 7 is 7, so 7 plus 1, so that's 8, no problem. What about f of -2? Well, that is mod of 2 times -2 minus 3. So 2 times -2 is -4, -3, so that is mod of -7 plus 1. Well, that is 7 plus 1, so that's also 8. So mod of so it turns out that f of 5 and f of -2 are the same thing. That's not too much of a surprise. We can have functions that have 2 inputs with the same output, not a problem. Okay. Now, what happens when we start sketching graphs? Well, if I sketch a graph, let's say I've got a graph that looks like this, and that is mx plus c. Well, what if I don't want mx plus c? If I want mod of mx plus c, what's it going to look like? Well, if we have a positive number in here, nothing changes, does it? So the size of this is the value it's already taken, right? But when things are negative, we're going to ignore the negative sign and make them positive, right? So say the y value here might be -3. What's mod of -3? Well, it's 3. So that, instead of being down there, will be up here. Let's say the y value here is -5. Instead of being -5, we want to plot it as 5. So what we're actually doing is we're taking everything below the x-axis, we're crossing it out, and we're reflecting it in the y-axis. So straight lines, instead of being full straight lines, we get the straight line we were expecting down as far as the x-axis, and then what we would have here, we've reflected it up here, okay? Now, we then need to deal with this as, we know the equation of this line, it's mx plus c. What's the equation of this line? Well, we know the equation of the points on this line. We don't have the whole of the line mx plus c because we've crossed out this half of it, all right? What's the equation of this line? Well, look, if this one here has got a gradient of m, this one here has got a gradient of -m, hasn't it? Because it's this line reflected. How do I make that clear if it's not clear to you? Let's think about it like this. If I go across 1 and up m, then here if I go left 1, I'm going to go up m, right? Because they're the same thing. So in other words, for every 1 I go across, I go m down on this line. For every 1 I go across, I go m up on this line, all right? So that's why it's -m. Where does this one hit the y-axis? Well, this one here hit the y-axis down here at c, and I've taken c and I've reflected it up here, so that value there is just, it's the same distance away from 0 as c was, isn't it? So it's -c, so -mx minus c. In other words, it's minus mx plus c. It's the equation of this line is the equation of that line with minus signs in front of everything, okay? So there are two tricks we've got so far. Well, there's sort of two tricks. One is if we've got a straight line and we want to take the modulus of the straight line, then cross off everything below the axis and flip the other bit upside down. So straight lines with a modulus around them are going to look like these sort of odd V shapes. The first half of that argument didn't need to be a straight line, and I'm getting ahead of myself a little bit here. This is later on in the chapter. But if this is f of x, and I want to plot mod of f of x, well, that means take x, put it through the function f, and then take the mod. So take x and put it through the function f, and I get this. If I take the mod, then anything that was negative, I need to cross it out and reflect it in the y-axis. Oh gosh, I can have terrible reflection, sorry. So mod of that function there, let me draw this again. Here's the function. Mod of the function looks like this. Oops. Okay. So there's the function. Mod of the function means cross these bits out, reflect them, and this is what we'd end up with. Okay. So there's the trick for how to draw a mod of any function, and there's also knowing that linear functions look like odd little V shapes. So what can they ask us? What sort of questions are we going to get? We're going to get questions that look like this. Now, as my class will tell you, sketch the graph, right? Any question you can, sketching the graph is always going to help you. So 2x minus 1, take the mod of that, that's equal to 5. What's that going to look like? Well, 2x minus 1 would be a graph that looks like this. So mod of 2x minus 1 will be a graph that looks like this with this bit crossed out. When is that equal to 5? Well, there's 5 on the y-axis, so we've got these 2 points here, okay? Now, what are these 2 points here? Well, this is the line 2x minus 1 is equal to 5. That will give me that solution there, but this equation has two solutions, these two here, and I can see that because I sketched the graph. This solution is the solution to 2x minus 1 equals 5, and that's easy enough to find. We've been able to do that for a long time, so we're going to get x equals 3 there. What about this one? Well, there's a couple of ways of going about that. What you could do is say, well, I know this is a V shape, which is symmetrical. So I could work out this distance here, this x distance here, and I can work out that x distance here because this is the point where this line hits the x-axis. Where does it hit the x-axis? Sorry, it's the point where the line y equals 2x minus 1 hits the x-axis. Where does y equals 2x minus 1 hit the x-axis? Well, it always hits the x-axis when y equals 0. So I could say x equals a half. So that distance there is from a half to 3. So that distance is 2.5. So if I go 2.5 this way, I'm going to get to this one because this whole shape is symmetrical. So the first option there is just sort of use the geometry of the situation, look at the picture you've drawn, use a bit of cunning, sort of be clever, and you can get an answer. The other option is, what's the equation of this line? Well, the equation of this line I know is minus 2x minus 1. Y equals minus 2x minus 1. Now, it's not the whole of that line, it's only half of that line, but it's the point where that line has the y value of 5. So if I solve that equation, I'm going to get this solution here. And again, that equation not too tricky to solve. So that is our method with these things. Let's just very quickly, I keep saying very quickly, and then don't know whether I go any faster or not, but we'll see. If I'm solving this equation, sketch the graph. 3x minus 5 has a gradient of 3 and a y-axis crossing point of 5, so would look like this. Mod of 3x minus 5 would look like this. Take this bit, cross it out, and reflect it up there. 2 minus a half x hits the y-axis at 2 and has a gradient of minus a half, so it looks like that. So y equals this is the V shape, y equals this is the straight line. I'm looking for these two points because when y equals this and y equals that, where do the graphs cross? That's the solutions. This one here is just 3x minus 5 equals 2 minus a half x. That is going to give me the solution at this point. What about this point here? Again, either use the geometry of the situation, use what you've drawn, use the fact this is a symmetrical V shape and think of something clever, or just say, well, this line here is minus 3x minus 5, and this line here is 2 minus a half x. Put those two things equal to each other, sorry, this line here is y equals 2 minus a half x. This line here is y equals minus 3x plus minus 5. And put those two equal to each other, in other words, solve the equation simultaneously, right? And we get this there. So we can find those 2x values that way. The biggest mistake people make is not sketching the graph. If you sketch the graph, you can picture the situation. So many times I see this in exams, and people try and solve this by just doing it algebraically, and you might have even spotted the pattern, right? Put a positive sign in front of this, put a negative sign in front of this, and work out the two answers. But honestly, if you can see the graph, you can picture what's going on, it's going to make it much easier. You're not going to make mistakes, because if they give you an unusual situation where that doesn't quite work, which they often will in an exam, you can picture it, so you're not going to fall for the traps. So for example, example 6, look, where they have an inequality in there. It should be simple if you've got the graph drawn, because you look at the crossing points and then you want one of the graphs bigger than the other. If they throw that in, you're not going to go wrong if you've got a graph sketched. Okay, that's section 2.1.